This is the ROS Developers Podcast, episode 55. Yeah.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate the episode to those ROS developers that use simulations as the key element in the ROS development. I mean, you use the simulation to test your programs, or your robotics programs, until they work properly in the simulation. And then, only then, you move to the real robot testing. So you are the professional ROS developers, and for you, this episode is dedicated to you. Today, it is my pleasure to introduce you Olivier Michel, who is the CEO of Cyberbotics. Cyberbotics is a company based in Switzerland that develops the Webots simulator. Today, Olivier is going to explain us about these Webot simulations, how can we use it with ROS, and about the latest movement that he and his company they have made about putting this simulator into open source. So let's hear Olivier and let's see what he has to tell us. Welcome to the podcast, Olivier.
Thank you. Thank you, Ricardo, for inviting me to this podcast. I'm happy to be there.
My pleasure, because, you and I, actually, we know each other from a long time already, so we have been collaborating a lot of times in our career. Do you remember when was the first time that we met?
We met at EPFL in, I don't remember, but maybe 10 years ago or more.
Or more. I think it was around 2005. And I was doing some part for the Webot simulator, specifically, about the simulation of the Aibo robot, the simulation of the latest model that they had for the Webot. Yeah. A long time ago.
Yeah. But the Aibo model is still there in Webots today.
Is it? Yeah, but it's a shame because we did a transfer to the real robot. So we could transfer the controllers from... Do you remember that we were doing this package? But now the Aibo is dead and that cannot be used anymore. Only the simulation.
Yeah. But today there's a new Aibo from Sony.
Yes.
That is commercially available, but it's not exactly the same as the one we used at the time.
Yeah, it's a new, and it works natively in ROS, that new version of Aibo.
Yes.
Is it Webot supporting this new model of Aibo?
No, we don't have it yet.
Okay. Working on it?
No.
Not yet. Okay. Well, someday. Actually, related to that, so I went to visit Sony in last December, and I was talking to the engineers there, and the thing is that they are not providing yet an SDK for programming the robot. So it's like a product, it's like so nothing that developers we can put our hands on it. So maybe when they decide to do it, I don't know. Well, anyway, so let's explain to the listeners, what is Webots?
Okay, so Webots is a robot simulator that we have been developing for the past 23 years.
Wow.
It basically, if you know Gazebo, it's very similar to Gazebo in terms of functionality. However, Webots is often considered as a software that is very easy to use, and it has a number of features which makes it very interesting for robotics research and teaching. Mm-hmm. So those features include, for example, the reproducibility of results. That is, you can run the same simulation twice and you will get exactly the same result at the end, which is not a property of many simulators available on the market.
That is right.
Moreover, Webots is known also for the accuracy of the sensor models. So we have a number of sensors coming from the robotics world, which includes lidars, camera, distance sensors, sonars, any kind of sensor, which have been calibrated against real devices so that their behavior, their response is very realistic as much as possible.
Yes, I have seen this feature that you have in the cameras, for example. In the cameras, that is this blur behavior of the camera. You know, because usually in the simulated cameras, everything looks very perfect in terms of the capturing of what is seen in 3D is. But in your case, I've seen those videos that you show when a real camera moves, it creates kind of a shade, the real one. So your case also, and your simulator, also this is reproduced, so you can see that effect.
So camera is a good example because camera are very accurate in Webots in the sense that we model many effects of real camera. So the one you mentioned is motion blur, but there's also focus, fuzziness, and we also model optical aberration. So we use a spherical projection instead of a planar projection, which is realistic with respect to CCD cameras. In addition to this, our camera can be 360 degrees, so they can be fully spheric camera. Also, the camera can have some noise, white noise on the camera, which have been calibrated against real cameras as well. We even calibrated radioactive perturbation on the image. So if you have a camera operating in a radioactive field, you can simulate the white dots that will appear on the camera depending on the radioactivity level. So that's a lot of things we have accumulated over a number of projects where we have been working with customers for improving the models of the camera. In addition to this, the rendering in Webots, in the newest version of Webots, is now even more photorealistic as before, in the sense that we're using PBR, that is physically based rendering, for much more accurate images and materials. We are using also ambient occlusion shadows, which gives very realistic images where you have very soft shadows between at the edges of objects. And also all this is accelerated on the GPU. So that includes standard cameras, but also lidars, rangefinders, and so on, so that every ray casting is actually done on the GPU. And so you get a very good simulation performance out of that.
Wow. Nice. And what about other features? Because you were saying more features, but I interrupt you with the camera specifically.
More feature regarding cameras?
No. I mean, you were listing, saying so several features that Webots possess. And then I interrupt you when you started to talk about the cameras and sensors in general. So,
Okay, So I can follow up with more features. I think we have a pretty good exhaustive library of sensors. That is, any sensor you can find in robotics, you will find it in Webots as a model. For those sensors, we provide generic model that you can configure yourself. So you can define the range of a distance sensor, the resolution of a camera, whatever. Or you can use what we call proto, that is a pre-configured sensor that corresponds to a real device. For example, Okuyo rangefinder with a specific model. And then you can pick this one and it's already properly configured and realistic with respect to the real device.
Okay.
So it's open to create your own model of sensor or to reuse existing models.
Yeah, in case that you want to move fast and then you trust already the model. So you say, for me, that it is, this model is what you actually need. So you don't need very, very specific details about this modifying. So you can use it in your model and then you go fast, you move fast in the simulation.
Yep.
Yeah. And you mentioned something very interesting that is about reproducibility, that you can rerun the same simulation again and obtain the exact same results. Yeah. And then, that's very interesting and also is very necessary, for example, when we are doing some unit testing or functional testing. So we want to test some routines inside an automatic system, and we use a simulation for checking if my program for navigation is able to make the robot navigate in this environment and reach the endpoint. And then I want that this test says yes or no all the times. And then for that, I only need that it goes to this path so I can reproduce the same result. But what about, for example, when we want to use the simulator for evolutionary purposes, where we need this kind of randomness into the system to also play a role into the simulation? Can we activate this in the simulation?
Yes, of course. If you need randomness, you just need to initialize your random number generator with the current Unix time, for example, and then you will get a different run at each time.
Okay.
So
yeah.
That's an option.
Okay.
That's the easy part. That's easy to do.
Okay.
What is difficult is to achieve reproducibility.
Exactly.
To achieve non-reproducibility is something easier.
Okay. Okay, very good. And then I was going to ask you how old is Webots Simulator. You already told me that it's 23 years old, but you didn't say why did you start it to create Webots on the first place?
Wow. Actually, I started to develop a robot simulator during my PhD thesis. That was a 2D robot simulator that was called Kepera Simulator. It's still available, open source, but it's like 25 years old. So I think nobody uses it anymore.
Well, I can tell you, sorry to interrupt you, but there is this stage simulator. You know the stage simulator?
Yes.
That is a 2D, and also, so there is many people that is using for simple algorithm control. The stage simulator, for those who doesn't know, is a 2D simulator provided together with ROS. So ROS provides gazebo in 3D, and then this stage simulator. And then maybe your simulator, Kepera Simulator is called, isn't it?
Yes.
So maybe could be useful because it's also a 2D robot that moves with rays and lasers and so on.
Yeah. So it was specific to the Kepera robot, and I did it during my PhD thesis because I needed to access a Kepera robot, and we had only one Kepera robot for the whole lab, and every PhD student was using it all the time, and I needed to run evolutionary computation on the robot, so it was taking a lot of time. So I decided to create a simulator so that it could run night and day in simulation, and that's why I created the first instance of that simulator. Then so the simulator, that was long time ago, that was 94, 90, something like that. So the simulator got very successful. That was the beginning of the internet, indeed. And it's got downloaded by many people, and I got many questions from people. And then I became somehow a little bit famous for that. And so I was invited in universities to give presentation about that. And especially at the EPFL, where the Kepera robot was invented. And they proposed me to continue the development of this simulator at EPFL as a postdoc researcher.
Wow.
And then I decided to drop the 2D simulator and to switch to a 3D simulator, and that was the first version of Webots.
Okay. Okay, so then we can say maybe that Cyberbotics, your company that developed Webots, is a kind of a spin-off of the EPFL?
Yeah, that's right. I started in 96 at EPFL, and I've been developing Webots at EPFL for 2 years. And in 98, I founded Cyberbotics as a spin-off from the EPFL to continue the development of Webots and to make it a commercial product.
Wow. Amazing. And so many years, so you have created this company, and So I build it bigger and bigger. I have seen how your company has been growing, because since I visited you and I was working with you on those IBOS simulations, then you started to incorporate more people at your company. And what I mean is that your company is old, based on robotics, and is successful. So that's a very strange thing, because the robotics companies, they are dying like, like flies. They're dying everywhere. Very good. Congratulations for that. And then another question, which physics engine it is based, the Webots simulator?
So it is based on the ODE physics engine, Open Dynamics Engine, but that's a fork of ODE because we patched a lot of things in ODE. In particular, we improved the detection collision, which was buggy because it was not generating enough contact point and a good quality of contact point. I mean, a good distribution of contact point for a stable physics simulation. So we improved a lot the quality and number of contact points generated between different primitives. We fixed a number of bugs, and we introduced fluid dynamics so that you can simulate fluids. So now in Webots you can simulate submarine robots or a boat. Wow. Or anything that involves fluid dynamics. So it's an efficient model of fluid dynamics. It's not finite element based, so it's not extremely realistic, but it's a good compromise between realism and efficiency. And we also introduced in ODE multi-threading, so that if you have a multi-core computer and if you have different physics system which are isolated from each other, they would run on different cores of the CPU, and so it will run faster.
Wow, amazing. Those changes to ODE are amazing. And maybe you mentioned one about the contact points, that it's a very important issue for example, in simulators like Gazebo, because I mean, in robots need to interact with the elements in the environment, so they need to grasp things, especially grasping. And in Gazebo, that's a pain. That it doesn't work very well. So it just in very specific situations that it works, but in all the others, it's everybody's complaining about this not being able to do grasps, real grasps in the Gazebo simulator. So.
Yeah. In any case, collision is something tricky in physics engine in general. We have been working a lot on fine-tuning our grippers, our every component that need a precise collision detection, so that they provide a very stable simulation. And the feedback we got from users is that Webots is much more stable when it comes to simulating a gripper, grasping an object, and so on. That's because a number of parameters were carefully fine-tuned in the physics simulation, including the primitive that get collided between each other, and all the ODE physics parameters.
Okay. Does that mean that in case that I want to build a simulation of my robot, then and I want that robot to do a proper grasping in Webots, I do have to do this tuning also for my specific grippers?
Yes, partially. I mean, some of the tuning is built in Webots, and some of the tuning is depending on the model, especially the primitive that you will use for collision detection. So, for example, I would recommend you to use rather simple primitive like cube or cylinders or spheres rather than meshes, because that will give you more stability.
Yeah.
But if you follow a couple of guidelines, you will get a pretty stable gripping simulation.
Okay, so in that case, what we can do is to make the visual aspect of the model as we want, so that's
sure.
Independent. But then the physical collision model,
yes,
that is the collision model as a simple shape, like based on cylinders, cubes, spheres, something like that. Okay. Nice to know. And then one thing is that Webots, based on its success, then has been used at the Human Brain Project, which is the flagship project of the European Union. So it's the main research project that we have at the European Union, the Human Brain Project. And then Webots has been used for simulating this. For what was the usage of Webots in that project?
So the plan was to use Webots as an online simulator that would be connected to the simulation of brains running on supercomputers, and that would help researchers to close the loop of the cognition process. That is, they could simulate sensor, then they could simulate cognition with the simulation of the brain, and then they could simulate actuation, and then actuation would generate different sensor inputs thanks to the simulation of the physical world, which will close the loop of the cognitive system. So that's basically to demonstrate learning processes inspired from biology, and to demonstrate that the simulated brain would behave as they pretend. So Webots, the plan was to introduce Webots in this platform. Currently, the platform uses also Gazebo, and for historical reason, they started with Gazebo mainly because Webots was not open source at the time they started, and now we are porting Webots into the platform. We're working on that.
Okay, nice. So if I have understood correctly, the setup would be that they have the Human Brain Project. They have kind of a simulation of the brain, which is made in another software, something different. Okay, so it's running in some supercomputers. They're running whatever. But then this brain simulation, in order to test if it is correct, if it is able to learn, if it is able to perceive, and so on, needs to be connected to something physical and to the world, but then connecting that to the world, that will be a little bit more difficult, because we'll need to kind of strange creatures, real creatures. So instead of making software in those strange creatures, then we use a simulator of the physical environment, which is Webots. And then you create some, I don't know, maybe it's a robot, or maybe it's a creature, also a simulated creature in there.
Yeah, so basically it's robots.
Robots, okay. And then this brain has to control these robots inside that simulated environment.
That's right.
Okay, makes sense. Okay, nice. So please let us know when you have this done, and publish videos, because that sounds like a super cool project. So we would like to know about that. Okay,
will do.
And then, so now you mentioned about this changing Webots into open source. So after many years, you decided to do this change from proprietary code into open source. So can you explain us what was the reason for doing that?
Yes, I wish I could have done this much earlier, because I consider open source very cool, and I wanted to contribute to this community of developer, right? The problem was that we have a number of people in the company, and we need to pay their salary every month. And it was difficult for me to envision a business model based on open source on such a niche market that would allow me to pay the salary of my people at the end of the month. So we had several attempts to get funding from public institutions, including the European Commission, to support a switch to open source, but we were not successful on those projects. And at some point, we decided that we would do it anyhow, mainly for several reasons. But one of the most important reasons was that we realized that some of our customers were preferring to use open source alternatives because they were afraid that we disappear and they would get stuck with a proprietary software that is not maintained anymore. And some of our customers told us that they would use Webots and they would pay us for developing things in Webots if it was open source. But if it remained proprietary, they would not adopt it. So that was something that made me think a lot. And then we discussed with those customers, and then we decided to turn Webots into open source. And that now we realize, so that is, we did that last December, so that is not yet 1 year. And we realized that we are getting a much better exposure now, including to the industry. And we have much more contacts from the industry because it's open source and because they know that if they start using it, they will be able to use it forever. They have a guarantee that it will never escape to them. And that's a strength indeed. And since then, we were not very confident when we, when you press on the GitHub button, make this repo public, but we did it, and it was difficult at the beginning, I have to admit. But now we see the light, at the end of the tunnel, which means we see that people are coming to us because it's open source, because they consider it's a high quality software, because they understand that there's a company behind this software that can help them, and they feel very confident, and we see this in our business sales currently.
Great story, and also very brave to make this decision. So I hope that you get a lot of customers and requests and support and projects and so on, because you deserve really. So for all the listeners, let me tell you how difficult it is to build such a software. So, I mean, you have to see. I will put some videos beneath this on the show notes. So you can see how it looks, the Webot simulator, in case that you don't know it before. It's amazing. And then also I will put a link to the Git. So in case that you get seduced by the videos, you can download it and do your own tests about that. Okay, and then how has been the reaction so far? So you mentioned that many people approached to you. So do you know of any, are you aware of any project that has switched from Gazebo or from other simulators like BREP or so into Webots?
Yes, we indeed have a lot of requests from users asking us to help them to transfer their Gazebo, VREP, or whatever model into Webots. So for this, we have developed, for example, a URDF to Webots converter, which is helping users to transfer their simulation from Gazebo to Webots in that case. But yes, and we have also some industrial customer, but I cannot disclose the names, who actually switched from Gazebo to Webots.
Okay.
And who paid us to help them doing that.
Oh, nice. Very good. Very good. And then we reach the point, because this podcast is called the ROS Developers Podcast. It's not the Simulators Developers Podcast. So how can we use Webots with ROS? Because at the beginning, Webots was not designed to work with ROS, because ROS didn't exist. So when ROS started, Webots was already a grown up. And then, so how can we, if we want to use Webots in our ROS projects, so what can we do? How do we operate?
Okay, so there are some very recent news regarding the use of ROS with Webots. Over the past few years, we supported ROS weekly. That is, we provided some ROS interfaces, but it was not very convenient to use. Over the past 3 months, we developed a series of tools and ROS packages that makes it much more easy to integrate ROS with Webots. we have released this Webots ROS package, which is based on ROS 1, and which is available on Kinetic, Melodic, and the old version for Lunar as well. So this package provides, for example, a launcher, which makes it very easy to launch Webots and the ROS nodes and everything, just like you would do for Gazebo. And but you still have to install Webots separately. So you have to install the Webots ROS package on one hand, and on the other hand, you have to install Webots. And then you can start the launcher to start the example simulation that we provide, and it behaves exactly the same as Gazebo.
Okay, and then if I have previously created simulation with Gazebo and I want to run this simulation into Webots, so apart from installing the Webot simulator and the Webots ROS package, so what do I have to do with my old Gazebo simulation?
So you have to convert your simulation from Gazebo to Webots, and for that we provide tools such as this URDF to Webots converter. Then, depending on the robot you want to control, you will have to adapt the topics, the ROS topics, and services, so that they will match your ROS node. So your ROS node could retrieve sensor information, send motor commands, and that's it, basically.
Okay. Do you provide any example of this into your Webots ROS package, so the people can find it?
Yes, we provide a few examples of simulations, but we do not yet provide a tutorial where you would start from a Gazebo simulation and you would convert it step by step to a Webots simulation. That's something we should probably do.
Okay.
But that's fairly easy to achieve, I think.
Yeah, so this URDF tool is also available. This
Yes.
URDF to Webots available. Okay.
Yeah, that's also open source, available on GitHub. And maybe in some case it's not necessary. In case you have the simulation in Gazebo which relies on a robot that already exists in Webots, then you can simply use the existing model of robot in Webots and adapt the topic names, service names, so that you will be able to connect, and that's it.
Yeah, like for example the PR2, that I have seen the PR2 simulation in Webot, that is amazing. And the grasping of the things that it does, how it grasps things and how it moves, it's amazing. So if my Gazebo simulation has a PR2 robot, then I can just delete that from the Gazebo simulation and then take a spawn, the PR2 version of Gazebo, and then do this adaptation of the topics and services and whatever. Okay.
Yeah. That will be much more efficient because the PR2 model in Webots is already well calibrated in terms of grasping, collision detection, and so on. So it will be much easier, and you will get probably a much better result than converting the Gazebo model to Webots, because then you risk to lose something or to have something that is not well calibrated.
Yeah. So then you are on the safe track because it's already been made for us by you. Oh, great. And then can I ask you, how does Webot simulation publish in ROS? So a Gazebo simulator, the Gazebo simulator, it's a non-ROS simulator. It's a non-ROS simulator. It's just a simulator of robots or whatever parts that require physics interactions. Then when you want to work in Gazebo with ROS, you have to load a plugin, the Gazebo ROS plugin, and then suddenly, so there is a ROS core, there is a node called Gazebo that is publishing everything related to the robot and the things that you have in your simulation. So for Webot, is it something similar? So you have kind of a plugin that you load into Webot, and then you have this structure?
Yes, so this is something very similar. Actually, we don't call it a plugin, but rather we call it a robot controller or a supervisor controller. So basically, a robot controller will control a single robot, whereas a supervisor controller will control the whole simulation. That is, it can move object around, it can record a video, it can apply a force.
Like a god. It's like a god
Exactly.
in the world.
Yeah.
Okay.
So both a robot controller and a supervisor controller could be ROS nodes and could publish topics and services to which you can get connected from ROS.
Okay, so that is the one that is in charge of translating between ROS and into the actual Webots controllers of the robots.
Yes, and that's very direct because those controllers are very close to Webots in terms of data connection. Yeah, for example, a controller will read a camera image directly into a shared memory segment that is shared by Webots. So there's no data transmission. The rendering occurs in this shared memory segment. Well, it occurs on the GPU, but then it is transferred on this shared memory segment and is directly available to the controller. So you're very close to the source of the data. There's no overhead, communication overhead.
Okay. Yeah, so I was asking you about that because I've seen other simulators that they want to make more realistic representations of the reality, and then they use engines like Unity or Unreal. Then all of them, the approach that they are doing is just by using a ROS bridge. So you have to launch a ROS bridge, then configure, and then it communicates via WebSocket with the internal. But there is this overhead that you mentioned about transferring data from one side to the other and having this artificial, ROS bridge there that is not that the purpose. So it's like an artificial thing of using.
Yeah, we actually considered this ROS bridge solution, but it was not efficient enough. I mean, in terms of performance for transmitting big images, there's an overhead which is not necessary and which makes the simulation, everything will slow down because of that.
Okay, great. Nice. And so let me see. So one question more. So in which language can we program the controllers of the robot? So can we program it in Python, in C++, any other language?
So if you don't use ROS, we provide a native interface to Webots, and with this native interface, you can program in C, in C++, in Java, in Python, in MATLAB, and that's it. Okay. Then if you use the ROS framework, then you can program it in whatever language is supported by ROS, so mainly Python and C++.
Yeah, because you get the messages and that's
yes.
And then you do internally whatever. Okay, and then you also mentioned about the distributions that is working. It's for ROS1, it's kinetic, melodic, and lunar. It's okay. And then what about ROS2? So what are your plans for ROS2? Do you have any plan?
Oh, sure, we do. We actually started a couple of months ago to very active development of ROS2. So we have currently, we are pushing on the ROS repo version of Webots for ROS Crystal, so which already works, and for dashing as well. So those version will be much better than the ROS1 version because we will use the same topics and services as other robots in ROS, as real robots, which means that you could run the same ROS node, exactly the same ROS node on the real robot, on the Gazebo, and on the Webots without having to modify anything. So it will be much better integrated in that sense. Mm-hmm. And we're going also to implement the DDS system, which is basically the communication system used in ROS2. So this DDS system will be implemented natively in Webots, so that the communication between Webots and ROS2 nodes will be very efficient based on those DDS system.
What do you mean by that DDS implementation by yourself? So you are implementing DDS.
We are using a DDS library in Webots, so that Webots will use this DDS library to communicate directly with ROS node.
Okay. So so you integrate inside Webots.
Yes.
So sorry, I understood that you were going to implement DDS, so to create your own implementation of DDS protocol.
No.
That's a lot of work. That's another 23 years. That's a lot. Okay, very good. Wow, now nice. So can we download your current version of Webots for ROS2 in case that somebody wants to
yes.
It's available?
Yes. Everything is open source, developed on a public GitHub repo. So it's on GitHub/Cyberbotics/Webots ROS2. But it's going to be released in ROS2 in the next few days or weeks, or I don't know exactly. It needs to go through the review process and to get accepted and so on. Previously, we were waiting for other packages like I don't recall the name, dmessage or something like that. That was blocking us because we had a dependency on that, and that was not released in Dashing. That was only released in Crystal. But now it's in Dashing, so now everything, we have all the green lights to push Webots on Dashing. So you can expect that in the next few days or weeks, you will be able to get this ROS2 from the official Crystal and Dashing repo.
Great, amazing. So I will put a link because I have been checking your Git before preparing myself, of course, for the interview. And then I checked and I saw that there was the Webots ROS2 package there. And so I'm going to put a link in the show notes directly to the repo that you mentioned directly. Okay.
Great.
Then final question. Why would you recommend to our listeners that they try Webots for the ROS development?
So I think from the feedback we get from people using Webots and people not using Webots, I think the best use case is if you start a new robotics project, I would recommend to give a try to Webots to see if that matches your expectation, if that corresponds to what you need to do. If you have an existing project and this project is running on the ROS1 and you plan to upgrade it to ROS2, then I would recommend to consider using Webots while migrating from ROS1 to ROS2. And in case you have an existing ROS1 project and you're using another simulator like Gazebo, in that case, if you're satisfied with Gazebo, then maybe it's not useful to switch to Webots, unless you want to have very accurate like camera sensors, or you want to have reproducible results, or you want some feature that is available in Webots and that is not available currently in the simulator you have. But converting a big simulation from Gazebo to Webots takes some time. So depending on your level of satisfaction of the simulation, then you may not need to upgrade to Webots, or you may want to try with Webots.
Great. Okay. Very makes a lot of sense. The comments, the options, the situations where Webots should be used instead of Gazebo. At least give it a try. Okay, so that is all for today. Thank you very much, Olivier. Are you going to attend to the ROSCON by any chance?
No, I was at the French ROSCON in June, but I wasn't able to attend the international ROSCON so far. But maybe next one, yeah.
Okay.
This is something I have to consider.
Okay. Maybe so. We'll see each other there. Yeah. So thank you
Hopefully.
very much, Olivier.
Thank you very much, Ricardo. It was a pleasure to have this interview with you.
It was our pleasure, of course. And for all the listeners, let me remind you that if you want to become a roboticist or an AI researcher applying to robotics, then you need to learn ROS. And because ROS is the standard in robotics. How can you learn ROS fast? How can you do it well? It's very simple. Have a look at the Robot Ignite Academy. We have created the 30-70 teaching method, which is based on 30% of the time learning the theory and 70% of the time practicing with simulated robots. We provide a complete path for beginners, starting by teaching you about Linux for robotics, Python for robotics, and then we go straight into ROS basics and how to build your own ROS robot, step by step. Have a look at www.robotignite.academy. And that is all for today. See you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.
The ROS Developers Podcast. The ROS Developers. The ROS Developers Podcast. The ROS Developers.